Hey guys, and welcome back to coolmathproblems.net. Just kidding, I'm just doing a math task. So today we're going to work on the task 4, and that is quite interesting actually. First of all, I like just writing down the original equation, which is f of x square root of x minus 2 plus 5. This is our original equation. Now to find the inverse, the first thing I like to do is I like to switch up the variables. So this is basically y, so it would be x equals to square root of y minus 2 plus 5. Now this 5 is kind of feeling lonely, it needs a little friend. So I'll subtract these 5 from both sides, leaving us with x minus 5 equals square root of y minus 2. Now we all know that each operation has an inverse operation. So the opposite of multiplication is division, the opposite of addition is subtraction, and the opposite of square rooting is squaring. So if we square both sides, what we'll basically get, well, this would cancel out the square root, and this, if we don't do the freshman mistake, would distribute. So, you know, by writing it down like this, times x minus 5, and then, you know, distributive property, our inner last, whatever, you would finally get the result of x squared minus 10x plus 27. And this is basically the inverse of our original function. Now let's graph it to find the domain and show the relationship between both graphs. This isn't the best graph, but it's more for us to get an idea. So if we have a point here, we have a point here, we have a few points here, a few more here, and here. Alright, the original equation, it would go 5, and it would go 2 like this, so it would go right here. And it would basically go, and I have a lot of space to work here, but it would basically do something like this, right? It would kind of have a shape like this, like exponentially. So the inverse should kind of mirror that. So if we go here, it would be 5 here, and then 2 down again. We start here, and it would basically go, it wouldn't be that steep, but you know, it would go like that. Don't have a lot of space here to work with. But basically, if we don't study the domain, it would just be a quite beautiful parabola. But that isn't what we're trying to find here. What we're trying to find here is the inverse. So we have to make clear that the domain has to be x has to be over 5. The domain being 5, or else if it's anything less, it would stop being the inverse, which defeats the purpose of what we're trying to look for. I would even like to add on top of this and find the relationship. So if we let y equal x, we would basically get a line like this, which what it would do, it would basically act as a mirror, which from here, you could choose any point here in these x, and you would, if you go up in the y, you would find, if you go up or down in the y, you would find the exact opposites of the number, basically, since these are the inverse. Now it's important to understand the idea of outputs and inputs. So you can choose any number basically, but for simplicity and because I tried a few numbers, I think 18 would work the best. So here we have x, 18. First of all, let's plug this 18 into the original expression. So the square root of 18 minus 2, which is basically the square root of 16 plus 5. We all know that the square root of 18 is 4. 4 plus 5 is equal to 9. So when x is 18, y is 9. So now let's plug in this y into the inverse function. Alright, so it would be y equals 9. If you square the 9, you minus 10. Again, square the 10, put in 9 whenever there's an x. So, and the plus 27 would be just all alone. Again, if we do this, this would be 81. This would just be negative 90, and this would be plus 27. Y equals 81 minus 90 would be negative 9 plus 27. That would be 18, which is fairly interesting because if we go back to what I've written before, between outputs and inputs, here we have x, and here we have y, and whenever we put 18 into y, we have 9. Whenever we put 9 into the inverse, we get 18. This basically is proving that this is in fact the inverse function, since you're undressing and dressing again the function, and whatever input you put in, you'll get an output, and when you put the output back in to the inverse equation, you will get back to the input. And that basically proves that it is in fact the inverse function. Thank you for watching.